Algebra 1, this is the video lesson for final review preparation for Chapter 8. As this says, there were only 3 sections of Chapter 8 that you're responsible for, and all of them have to do with the rules of exponents. I'm going to show you a bunch of different examples, but the first 3 examples that I'm going to show you will cover the 4 different key points that you need to know about rules of exponents. Everything else tends to build off of those 4 rules. As I say, it's 4 rules coming out of the first 3 examples. You'll see why in a minute. The first rule, well, when you have matching bases, all of these have the base 2, you can add their exponents. Notice this is actually 2 to the first, and of course that's 2 to the second, and so on. So I add the 1 plus the 2 plus the 3, and I get 2 to the 6th. I am not going to expect you without a calculator to be able to tell me what 2 to the 6th is, so that would be a perfectly fine answer. If you had a calculator, you should be able to tell me that 2 to the 6th is 64. Second example. This time, I've got an exponent inside and an exponent outside parentheses. In this case, you distribute or multiply the exponent that's outside to the things inside. So, 3 to the 2 times 2. Well, that's 3 to the 4th, and with or without a calculator, you could figure out that 3 to the 4th is the same as 81. Without a calculator, I would be okay if you left it as 3 to the 4th. Third of these key examples, 3 to the 3rd over 3 to the 4th. Once again, I've got the same base. Both of these have the base 3. When one's on top and the other power is on the bottom, you subtract the exponents. The top one minus the bottom exponent. So I've got 3 to the 3 minus 4. 3 minus 4 is negative 1. But you don't stop here, and this brings us to that 4th rule that you need to know. If you've got a negative exponent means the base is on the wrong side of the dividing line. Right now it's above ground, if you want to call it that, above the dividing line. Put it below. And then you no longer will have a negative exponent. Once you switch it to the correct side, the negative exponent goes away. So you could call this 1 over 3 to the 1st power, but I've just written it as 1 over 3. From now on, all the other examples that I'm going to show you are going to build off of those 4 key rules, as you'll see going forward. Here's the first one. I've got matching bases. All of the things that have exponents have base x. I do have some 4's mixed in here, but notice the exponent is never next to any of these 4's. So the exponent doesn't apply for any of these 4's. I find it much easier to rearrange problems like this when everything's being multiplied, and in this case everything is, to rearrange it to put numbers next to numbers and letters next to letters. So I've rearranged it this way, 4 times 4 times, and then here's the string of all the different x terms. Well, 4 times 4, of course, is 16. And the x's, well, remember what we did on the very first example. You add those exponents because the bases are all the same. 4 plus 2 plus 2. So I've got 16x to the 8th. And that's my answer. Another example straight from that packet that I've given you. And do remember, like with all these videos, you can hit the pause button whenever you like and study what I've written down as much as you want to. But I'm going to just keep moving forward in the interest of time. Okay, I said that when an exponent's on the outside, you distribute it to everything that's inside. Well, this 4 needs to get distributed to the 2 just as it needs to get distributed to the x to the 4th. So I'm going to have 2 to the 4th, and remember, with this x, I've got exponents inside and outside, so I multiply them. That might be a little hard to read with my handwriting, but that's supposed to be a multiplication sign. So I've got 2 to the 4th, x to the 4 times 4. Well, of course, 4 times 4 is 16. And like I said before, I'm not going to worry a whole lot if you don't figure out what 2 to the 4th is without a calculator. You should be able to figure that out, and should be able to figure out that it's 16. Certainly, with a calculator, you should be able to figure out it's 16x to the 16th power. Next example. Now I've got quite a few different things inside parentheses with a 3 on the outside. The 3 gets distributed to each individual piece. So I am going to have 2 to the 3rd, m to the 3rd. The n is going to have 4 times 3, and then p is going to have 2 times 3. So let's work those terms out. We've got 2 to the third, m to the third staying the same. 4 times 3 is 12, 2 times 3 is 6. This is a perfectly acceptable answer, but you really ought to know 2 times 2 times 2 is 8. And this is a more finished and more polished answer here. And that's what I think you should be shooting for. Next example. Now I've got multiple things on top and bottom of the dividing line. Remember, the exponent only goes to the ends. So sometimes I find it easier to separate these ideas out with a multiplication sign. I've got 3 over 4 times n to the fourth over n to the third. Well, 3 over 4 is the same 3 over 4 that you learned back in elementary school and middle school. It's 3/4, or 0.75 if you want to call it that instead. But I saw a number of students who tried to do 3 minus 4 here as though they were trying to do something tricky. That's not part of the exponents rule. There are no exponents here for you to be subtracting. It's just the 3 and the 4 bases. Okay, so keep the 3 and the 4, but I've got n. Well, remember what the rule is when you're dividing. If the bases match, subtract the exponents of 4 minus 3. So I end up with 3 to the, you could call it n to the 1 if you want to, over 4, and that's my final answer. Continuing on. This time I've got a negative sign, otherwise what I had looks a lot like the last slide, except for this fact. I also have a negative exponent. Once again, I'm going to separate numbers from variables. I've got negative 2/3 on the left. On the right, I've got n to the first over n to the negative 2. Well, I'm going to keep the negative 2/3 as it is, but I'm going to change this to n to the 1 minus minus 2. Notice, remember the rule is subtract. Well, I'm subtracting a negative. Well, 1 minus minus 2 is 1 plus 2, or in other words, 3. And that gives me my final answer, negative 2 over 3, and also above the dividing line is n to the 3. Continuing on. Okay, this time, and this is something I haven't mentioned before in this video, but certainly have a number of times in class in preparation for your exam on Chapter 8 back in May, anything to the 0 power, the whole power here is 1. So you can just change that to 1, and that's what I've done here. I've just rewritten it as 4n to the 3 over negative 3 times 1. Well, negative 3 times 1 is negative 3. And so there's not really anything left to change. The rest of this is simplified down as far as I can go. And so that's my final answer. And this, I think, might be our last question, or we're getting close to the end at any rate. Yeah, this is our last question. All right, so there are a number of things going on here that combine a lot of the ideas I've talked about in this video. I'm going to have to distribute the 4, and I'm going to have to put the x's together, the y's together, and separate everything out. Well, first, let's just do that. The 3 times the 4, like I said, and put the x's together and the y's together. I've left the 2 over here to the right. Most of you probably would be happier if I put it to the left, but it doesn't really matter either way. Okay, this 3 times 4 is going to become 12 over here. The 2 plus 0 is just going to be 2. 4 plus 3, well, I've written it as 4 plus 3. I should have written it as 7. I didn't. And this 2 is on the bottom of the dividing line, so it's really times 1/2. Now, I think I'm going to fix, if I remember right, that confusion that some of us might have had by having the 2 off to the right here. Yeah, I put the 2, the 1/2 in the front now. So I've got 1/2 negative x to the 12 minus 2, 1 over, now I've done that, 4 plus 3, and made it into 7. Let's clean this all up one last step. Oops. Negative 1/2. 12 minus 2, that's 10. The negative that's here came from here. I just moved it next to the 1/2. So I've got negative 1/2 x to the 10th. Remember, the y to the 7th was below the dividing line. It stays there. And that's my final answer. And that is, in fact, the final example for Chapter 8.